Hello. Over this past year, CMG has migrated to a quarterly development and release cadence to accelerate getting new updates and features out to our clients and the industry. In this video, we will be covering some of the highlights of the most recent 2023 first quarter release made available at the end of March. Now, not every feature or update will be touched on in this video, so for further information on all the new developments, please refer to the What's New documents that are installed with the software as well as the manuals. To keep up to date with recent news and development updates, please check out CMG's website. We recommend following CMG on LinkedIn. And please consider subscribing to CMG's YouTube channel, which contains a variety of how-to videos and webinars on a wide array of solutions, workflows, and topics. For any questions or feature recommendations, please feel free to contact our customer success and consulting team by messaging support@cmgl.ca or our sales team at sales@cmgl.ca. The Builder and Results applications are CMG's guided menu and wizard-driven tools, which enable engineers in the creation of simulation scenarios and subsequent viewing and understanding of the results. For this past quarter and extending into the next, main development themes are centered around enhancing the speed, stability, and performance of these interfaces. In order to ensure a seamless user experience, emphasis on these themes will provide even greater efficiency to subsurface workflows. With these themes in mind, one particular area of recent development is associated with the stability and speed of accessing and using results across certain network environments, such as when your simulation outputs are stored on a common network location that's different from where you're using the results application. A new option provides an alternate method to how the output files are saved, which subsequently can overcome this type of cross-network issue. The option can be enabled by a switch or keyword input into the run, but will only work with the most recent versions of the simulators and results. So if you believe that you're facing these types of slowdowns in cross-network environments, then we encourage you to reach out and we'd be happy to walk you through this new option. Also, in relation to results functionality enhancements, the ability to define boundary polygons and export shapefiles was incorporated into this first quarter release. The title is a bit vague, so let me explain the problem statement and the application. In some workflows, such as carbon capture and storage, or CCS modeling, it may be important to see the areal extent that fluids or pressure changes may move, like when you inject CO2 and need to see how far away from the injection site it might migrate over time in order to de-risk for permitting and in applications, or to define effective monitoring and verification programs, MMV. A common approach is to export from the models to then overlay on a map or other information in order to determine the potential extent and impact. With the new capabilities, you can define areas of interest and then export them as shapefiles, which can then be brought directly into a GIS application for further comparison and analysis. Now, this new option greatly reduces the time such a task would have previously taken. Chances are that if you've conducted a history matching simulation study before, that the relative permeability was one of the inputs you likely altered to get a match. In general, rel perms can be one of the more uncertain data that we engineers deal with. If lab data is not available, then it's common for a Cori or LET type correlation to be utilized in generating the relative permeabilities based on certain curve endpoints and curvatures. However, for each scenario you would want to test, you essentially need to define and export a new rel perm to use. And this takes time, and file management itself can become an issue. With the latest update, though, we can now specify that parameters associated with those same Corey and LET type correlations can now be directly input into the simulation model, making it easy to update on the fly or to flag as an uncertain parameter for CMG's CMOST uncertainty and optimization tool to then investigate. Moving to the simulators, STARS saw a nice addition in regards to a new viscosity mixing rule. Historically, viscosity mixing, or how a phase's effective viscosity is calculated from the various components which make it up, was done via considering density differences, where higher density components had higher weighting in the calculation. However, when working with processes involving solvents, such as solvent steam co-injection, the lab or field results demonstrated that in some of those situations, a volume weighting approach provided more accurate results. So this new approach has been added now into STARS, and we recommend giving it a try for your solvent-based models in particular. Now we are very excited to announce that with the release of MPI and IMEX, all three of CMG's core simulators, STARS, GEM, and IMEX, are now available as hybrid MPI-enabled versions. With hybrid MPI, you can run models across hundreds or thousands of compute cores, spread across many computers or nodes. In particular, CMG's cloud environment enables access to any number of resources that are required for running simulations of any size or complexity now. As an example, we saw a large steam-assisted gravity drainage, or SAGD, model's runtime drop from 17 hours to only an hour and a half through the use of MPI. With the extension of this to IMEX, which is already the world's fastest black oil simulator, the sky is truly the limit in terms of the application and the value that can be garnered. And in saving the best for last, CMG's CMOST tool has been officially re-released with all new capabilities. Just as our field operations may evolve based on the outcomes of a CMOST optimization study, so too did CMOST itself evolve based on the updates in workflows. Now, if you're not familiar with CMOST, it is a powerful tool which leverages proxies, machine learning, and intelligently running sensitivity analysis, history matching, optimization, and uncertainty assessment studies. Over this past year, CMOST was re-architected from the ground up to provide ever greater capability and flexibility in running more and larger studies and improving usability when there are many realizations or parameters of interest or experiments, really removing all the limitations which previously may have existed in these types of studies. Along with these functionality enhancements and the enablements, this new version of CMOST is also able to link not only with CMG's core solution suite, but our CoFlow platform as well. CoFlow is CMG's integrated production systems modeling, or IPSM, and production engineering application. To boot, CMOST is cloud integrated, providing the ability to run simulations directly in CMG's cloud environment. Lastly, an enhanced methodology for setting up and running a robust optimization study was also introduced. Robust optimization is arguably one of the most powerful tools in our engineering repertoire, where you can find the most optimal operational path forward while simultaneously taking into consideration all of the geologic and other unknowns that you might have, even in terms of price decks and economics. In this way, you and your stakeholders can have confidence that the path being recommended or pursued could be successful no matter what the underlying risks truly are. With that, thank you for your time in listening to the What's New for our 2023 first quarter release. We look forward to your feedback on the new versions as we look to further enhance the user experience and value that these tools can provide. Thank you.